nonlinear systems. We have one objective here: to solve a system of nonlinear equations using either substitution or elimination. In this section, we'll be solving nonlinear systems where one or more of the equations will be nonlinear. Nonlinear systems of equations. One method of solving a nonlinear system of equations is the substitution method. This works best when one of your equations is linear and easily solved for one of the variables. Step 1 is to isolate a variable in the linear equation. This just means that you need to solve the linear equation for either x or for y. Step 2, you'll substitute that into the nonlinear equation. Step 3, solve the resulting quadratic equation. Step 4, we'll back substitute to get the other variable. Step 5, write down the ordered pairs. Let's solve this system. 2x squared plus 3y equals 8 and negative x plus y equals 2. With substitution, we'll go ahead and solve. Let's solve the second equation that is linear. I'm going to solve it for y. Y equals x plus 2. Now that we have that, we can substitute into the other equation to be able to solve for a variable. So I have here that y is x plus 2. I'm going to substitute x plus 2 in for y in the other equation then. So this is going to give me 2x squared plus 3 times x plus 2 equals 8. Now we need to go ahead and distribute the 3. I have a quadratic equation here, so I'm going to try and get everything on one side and factor. 2x squared plus 3x minus 2 equals 0. Let's see if we can factor this. This is going to be 2x times x to get me a 2x squared. If I can put a 2 here and a 1 here and make this positive and this negative, that will give me the negative 2 that I need for c. And 4x minus x gives me the 3x that I need in the middle. So from the first factor, I'll have x equals 1/2. From the second factor, I'll have x equals negative 2. Now, when we're solving this system, we need to recognize that these are going to be points in 2 space. So we need to have y's that pair with these x's. So let's start over here with x equals 1/2. And I'm going to put this into the simpler equation. I'll put it into the second equation that is linear, and that gives me a negative 1/2 plus y equals 2. If I add a half to both sides, y will be 5/2. So this means that when x was 1/2, y was 5/2. That's one of my solutions. I still need to solve for this other one when x is negative 2. So again, put it into the simpler equation. So the opposite of negative 2 plus y equals 2. This gives me 2 plus y equals 2, and subtracting 2 from both sides, I have y equals 0. So this gives me the solution of x is negative 2 when y is 0. 2 solutions for this system. Now I want to show you what this looks like graphically. The first equation given was a quadratic, a polynomial, and the second equation given was a linear equation. The solutions are where the line and the parabola intersect, so we have those two solutions plotted here. Next up we have this system. 3x squared plus 2y squared equals 11, and 4x plus 2y equals 8. Alright, so we're going to use substitution. Let's go ahead and solve one of these. We're going to solve the linear equation. 2y equals 8 minus 4x, and y equals 4 minus 2x. Now that we have it solved for y, I'm going to take that y and substitute it in for y in the other equation. When I do that, I'll have 3x squared plus 2 times the y value that I solved for in the linear equation squared equals 11. So 3x squared plus 2 times 16 minus 16x plus 4x squared equals 11. 3x squared plus 32 minus 32x plus 8x squared equals 11. Now, I have some like terms that I can put together, but ultimately I see this is a quadratic. It's going to have to get set equal to 0 and will factor. So let's go ahead and combine the like terms of 11x squared from my 3x squared and 8x squared, a negative 32x, and a positive 21, which equals 0. Now, to factor this, remember you can factor using whatever method that you're used to. I'm going to split up the 11x squared as 11x and x, and then I have both of the signs will be negative, and if I can put a 1 here and a 21 here, this is going to give me a negative 21x minus 11x, which is my negative 32x. Alright, now I have from this factor x equals 21/11, and from this x equals 1. Again, we have to have ordered pairs for our solutions. So I'm going to have for x equals 21/11, I'll put that back into, again, the simpler equation. 4 times 21/11 plus 2y equals 8. So this is 84/11 plus 2y equals 8. If I subtract 84/11 from both sides, I'll have 2y equals 4/11, and I'll multiply both sides by 1/2 to get rid of the 2 that's in front of the y. That gives me a 4/22. So this means when I have an x of 21/11, I'll have a y of 4/22. For the second x, x equals 1, again, put it into the simpler equation, the linear equation. 4 times 1 plus 2y equals 8. This is 4 plus 2y equals 8. So 2y equals 4 and y equals 2, giving me a solution of x being 1 and y being 2. Again, I'd like to show you what this looks like graphically. The 3x squared plus 2y squared equals 11 is an ellipse, and then the 4x plus 2y equals 8, of course, is linear, so it's a line. And the line intersects that ellipse in the two places that we found in our solution, the 1, 2, and 21/11ths, 4/22. Let's solve this system. The first equation is already solved for y, so I'm inclined to use x plus 1 in place of y in the second equation. X times my y of x plus 1 equals 2. Okay, I'm going to need to multiply out, so this gives me x squared plus x equals 2. And now we see that we have a quadratic. I'm going to need to get this on one side equal to 0, and I'll factor. This is an x plus 2 and an x minus 1 equals 0. And I get an x of negative 2 here and an x of 1 here. And again, we are going to need to find the y's that go with these x's in the solution. So these both are about similar complication. I like y a little better. It's a little cleaner. So I'm going to go ahead and put my x in there. Y equals a negative 2 plus 1. So y is negative 1. That gives me the ordered pair negative 2, negative 1 as a solution. And this other, y equals my x of 1 plus 1. I get y equals 2. So this means I have 1, 2 as my solution. Again, I'd like to show you what this looks like in graph form. So we see the red line is that linear equation, and xy equals 2 are the curve parts in green, and my solutions negative 2, negative 1, and 1, 2 are the places where the line and the curve will intersect, the solutions to that system. Now, systems of equations with two nonlinear. We have an elimination method that we can use also. Remember, we use those with linear systems. But this works really well with a system that has two nonlinear equations. So let's use that for this system. Now, remember, the idea was to remove a variable by adding equations where you have opposite terms. And y squared and y squared, those are the same. So I could quickly modify my second equation, or even the first, by multiplying both sides by negative 1. So I'll do that. I'm going to copy down the first equation. And then if I multiply the second equation through on both sides by negative 1, I'll have a negative x squared minus y squared equals negative 10. And now I'm ready to add. 4x squared minus x squared is 3x squared. The y squareds go away like we had planned. And 13 minus 10 is going to be 3. So that is x squared equals 1. And then I'll get x equals plus or minus 1. Remember, when it is your job of putting the square root on when you're solving this, it's also your job to put the plus minus there. If you don't do that, then you'll end up missing at least half of your solutions. It depends on how complex these can be. But if you make this same type of mistake twice in this problem, you'll end up missing 3/4 of your solutions. So make sure to not neglect the plus minus on your answers here. So let's see what happens if x is 1. And the two equations we have are of equal complication, but I'm going to put it into the second one just because the numbers are smaller. So I have 1 squared plus y squared equals 10. So that's 1 plus y squared equals 10. Y squared equals 9. And y equals plus or minus 3. So this means that when x is 1, I get 3. But also, when x is 1, I get a negative 3. So I get two solutions just out of that one x value. Now let's do the same for x equals negative 1. Let's say I have my negative 1 squared plus y squared equals 10. And from here, we can see we have the same as what we had over here. So I'm going to continue down and just say this is y equals plus or minus 3. This means that when x is negative 1, I get a y of 3. And when x is negative 1, then y is also a negative 3. Let's take a look at the graphical view of this system. With this system, we can see we have the top equation is the equation of an ellipse, and the bottom is the equation of a circle. And they happen to intersect, in this case, in 4 spots, the 4 solutions that we found.